Hey everyone! Welcome back to the channel. In today's video, we're going to learn how to update data using the Entity Manager in JPA. We already saw how to use pessimistic locking to safely fetch data. Now it's time to perform the actual update operation on that data. Alright. So in the last video, we wrote the code to fetch data using pessimistic_right locking with Entity Manager. That ensured our row was safely locked for updates, just like using for update in SQL. Now in this video, we'll implement the actual update method, the one that modifies the data in the database. Alright. So remember how in plain SQL we were updating the employee_name, age and department fields for a specific employee? We're going to do the exact same thing here, but this time using JPQL instead of raw SQL. First, let's try updating using JPQL, since that's closer to SQL and easier for us to convert. Go ahead and copy your SQL update query. We'll just make minimal changes to convert it into a valid JPQL query. Let's paste this inside our update employee method in the Employee Entity Manager repository class. And now, let's start converting it. Watch on screen as I make those changes. It's simple. In JPQL, instead of using the table name, we use the entity class name. And instead of using column names, we use the field names from the entity. And yes, we already covered this in one of our previous videos, so this should feel familiar. Alright. Let's go ahead and execute this update. Just like we did for the select query earlier, we'll call the create query method on the Entity Manager and pass our JPQL update query. Next, we need to set values for the named parameters we used in the query. First, set the employee name. Then the age. After that, the department. And finally, the employee ID. Now, check this out on my screen. The Entity Manager provides a method called executeUpdate. This method actually runs the update query on the table and returns the number of rows that were affected. Now just call the executeUpdate method to trigger the update. And that's it. Let's start the application. Okay, next up, I'll be updating the details for the employee assigned ID 24. As you can see on your screen, the information we currently have is employee name, Harsh Patel, age 31, department, QA. Now I'm going to update the name to Harsh Kumar and change the department to developer. Awesome. The update API call was successful. Alright. First, let's switch over to IntelliJ. See in the console logs, our update query has been executed successfully by the EntityManager. But wait, you might have noticed that 2 update queries appeared in the logs. Why is that happening? Don't worry, I'll explain exactly what's going on with those 2 update queries a bit later in this video. Stick around, it's actually pretty interesting. But for now, let's stay focused on our main goal, exploring multiple approaches to updating records using EntityManager in JPA. Alright. Now let's quickly verify if our update really worked. I'm going to hit the Get API for Employee ID 24 and check the latest data. And, see on the screen, the employee name is now Harsh Kumar, and the department is updated to developer. Next up, we're going to update the data using the Criteria API. Just like we earlier used it to fetch data with Criteria Query. So the idea is the same, but this time instead of selecting, we'll perform an update operation. Alright. Step 1. Just like before, we first need to get the Criteria Builder object from the EntityManager. Next, in fetching we used Criteria Query. But here for updates, we'll use Criteria Update instead. So from our Criteria Builder, we call Create Criteria Update, and pass the entity class, in our case employee.class. This tells JPA that we want to build an update query specifically for the employee entity. It's a bit different from select queries. Next, just like in Criteria Query, we need to get the root object to specify which entity we're updating. You can get it by calling either getRoot or from method on the Criteria Update object. Both work the same. This root represents the employee table, and using it, we'll set the fields and build our where condition. In a criteria query, we only specify which columns we want to fetch, right? But here, since we are doing an update, we have to tell it exactly which columns to update and their new values. See, the criteria update object provides us the set method to specify the update. This method takes 2 parameters. First, the column name, which we pass using the root object. This tells which field we want to update. And second, the new value we want to set for that column. Okay, just follow along like I do. First, we'll set the employee name. Then the age. And finally, the department. Step by step, just like this, updating each field with the new values we want. Okay, now we need to tell JPA exactly which employee to update by adding a where condition for employee ID. This is just like how we filtered results when fetching data with a criteria query, but here we're updating. Let's call the where method on our criteria update. And build a predicate for employee ID using the criteria builder. This predicate ensures we only update the employee whose ID matches our target value. Okay, now it's time to execute our update. First, we'll call the create query method on the EntityManager and pass in our criteria update object. Next, we'll call executeUpdate on that query. This method actually sends our update to the database and returns the number of rows affected. Alright, everything is set. Let's start the application to test our criteria API update. Alright, now we're going to update the same employee, ID 24 again. This time we'll revert the name back to Harsh Patel and change the department back to QA. Hit the request. Great, our update call returned success. Now, let's hit the Get API for employee ID 24. Look at this, the employee name is showing 24. See, I accidentally passed the employee ID into the set method for employee name in our criteria update. Alright, I fixed the mistake. Now let's restart the application so our changes take effect. Call the Update API again for employee ID 24. Fantastic, our update was a success. Now let's hit the Get API for employee ID 24 and check the result. See on the screen? The name and department are correctly updated to the new values. Everything looks perfect. Alright, let's check our console logs. See the last update statement generated by our criteria update? You might also spot two update statements here. Don't worry about that extra query for now. We'll break down exactly why it happens later. For the moment, just know that the final update query is the one that really matters. Okay, so far we've been writing JPQL and criteria builder code manually, long, repetitive, and frankly quite tedious. Check this out, the EntityManager already gives us a merge method that does exactly what we've been doing with JPQL and criteria builder, but in one simple call. You literally don't have to write any query or build any criteria. Instead, you just create an employee object with the new values, name, department, age, etc., and pass it to merge method of EntityManager. Under the hood, JPA will find the existing record, update its fields, and save the changes. It even returns the managed entity back to you so you know the update was successful. This means no more writing long queries. Just work directly with your Java object and let JPA handle the rest. Now let's call the merge method. Simply pass in the employee object that has our updated values. Awesome, that's it. Just one line of code using merge, and we're done. Now let's go ahead and start the application and test this out. Okay. I'm going to update the same employee again, ID 24. But this time I'll change the employee name to Harsh Kumar and the department to developer. Alright. The update was successful. Now let's hit the Get API to verify the changes. And yes, there you go. The employee details have been updated. Okay, Now let's switch to the console logs and take a look at the actual update query JPA executed. Interesting. You can see that joining date is also included in the update statement. But we didn't change it, and we don't want it to be updated either. So how do we fix this? Simple. Just go to your employee entity class. And on the joining date field. Here, we just need to update the @column annotation by adding one small attribute. Updatable equals false. This tells JPA not to include this field in any update statements. It's done. Restart the application. Alright, let's hit the API again. This time I'm updating the employee name back to Harsh Patel and department to QA. It's a success. Now let's quickly hit the Get API and verify the changes. And yes, we've got it. The name is updated to Harsh Patel and the department is QA. Check out the console logs. Notice that this time the joining date is not included in the update query. Alright friends, now let's understand something really important and interesting, and this might clear up the confusion you had earlier. You might have noticed this. When we used merge, only one update query was fired. But when we updated using JPQL or Criteria API, suddenly there were two update queries in the console. Why is that happening? Let me explain clearly. First, look at what we did before calling the update. We called a method named findByEmployeeID for update. This method fetches the employee data and also applies a lock, which means it returns a managed entity. Now here's where it gets interesting. When an entity is in a managed state, the Entity Manager keeps a close eye on it. Any changes you make to this object will be tracked internally. So when we updated employee name, age and department on this same object, Entity Manager silently noted, okay, this entity has unsaved changes. Now the twist. Before your manual JPQL or Criteria update is executed, the Entity Manager says, wait, I have some dirty changes to flush first. And that's why it fires one automatic update query first to sync those changes. Then after that, it executes your actual update query. Result? 2 update statements in your console. But when you call merge and pass your updated employee object, it does not immediately run an update query on the database. Instead, it does this. It takes your detached entity, meaning the object you created or modified outside of JPA's current context. Then, it copies all those changes into the managed entity that JPA already knows about in its current session, inside the Entity Manager's memory. At this point, the entity inside Entity Manager is dirty. That means it has unsaved changes. But JPA waits. It does not rush to hit the database immediately. Instead, it waits until the transaction commits or when it's time to flush changes. Only then does JPA generate the actual SQL update statement and save those changes to the database. Why this approach? Because it's more efficient. Instead of running multiple queries as soon as you change something, JPA batches and optimizes updates so your app runs faster and smoother. So, using merge is like telling JPA, here's my updated data, please sync it with what you're managing and save it when you're ready. You don't have to worry about manually managing the update queries or locking. JPA handles all that behind the scenes for you. Okay, now let's tackle a very important question that comes up a lot. How do we make sure JPA runs only one update query when using JPQL or Criteria Builder? Because right now, if you noticed, when we fetch the entity first and then execute an update, JPA actually fires 2 update queries. But don't worry, we can totally avoid that. So what I'll do now is, I'll quickly copy our previous JPQL and Criteria Builder update code and paste them inside our demo controller and demo entity repository just to simulate a fresh, clean call. Copy the findByEmployeeID for update method. Next, copy the update employee method. Alright, so to keep things super simple and focused, in this update method, I'm going to use only JPQL for updating the employee data. The same concept applies if you're using criteria update instead of JPQL. Alright, now let's quickly move things forward. We're going to copy the update employee method from our employee service and paste it into the controller class. We'll just expose it as a REST API so that we can hit it easily from Postman. Awesome, we've successfully copied everything and created our REST endpoint using JPQL. Alright, see here, the reason we were getting 2 update queries earlier is because we were modifying the existing employee entity directly. And since that entity is already managed by the EntityManager, any changes we make to it are automatically tracked. So what's the solution? One simple way is to create a new employee object, set only the fields we want to update, and then pass that to our update method. This way, JPA won't detect any dirty changes from the old managed entity, and we'll get a clean single update query executed, exactly what we want. Okay, let's go ahead and create a new employee entity object. We'll set all the updated values manually, like employee name, age, department, and of course the employee ID, because without that, JPA won't know which row to update. Alright, everything is set. We've created a fresh employee object, filled it with the updated data, and passed it to our update method. Now let's restart the application. Alright. This time, I'm updating the same employee again, but this time, I'll update the name to Harsh Kumar and set the department back to developer. Oh, looks like we got an error. That's because I quickly created the REST API as a post, but for updates, the correct method should be put. Let me fix that real quick, changing the API to use put instead of post. Alright, now let's restart. Okay, now I'm hitting the API with the updated data, changing the name to Harsh Kumar and the department back to developer. Now, let's quickly hit the Get API for the same employee ID to verify our update. Check this out. The name is Harsh Kumar and the department is developer as expected. Check out the console logs.
See this?
Only one update query executed this time. This is because we created a new employee entity and passed it directly to the update method, so JPA didn't track any dirty changes on a managed entity. That's how you avoid multiple queries and keep things efficient. Now suppose you don't want to create a new entity every time, and want to update using the same entity you fetched. How do you do that? Well, EntityManager provides a detach method. When you pass your entity object to detach, it removes that entity from the persistence context. That means the entity becomes detached, no longer managed by JPA. So, if you modify it later, JPA won't track changes automatically. Restart the application. Okay, now hit the API again with employee name as Harsh Patel and department as QA. Great.
It's a success.
Now quickly verify. See, the updated details are reflected perfectly. Now let's look at the console logs closely. See here, only one update query was executed this time. That's because when we detached the entity before updating, EntityManager stopped tracking the old state, so no extra updates happened. Hope now it's clear why two update queries were running before. When we updated a managed entity directly, EntityManager detected changes twice, once when we modified the entity and again when we ran the explicit update query. But when we detach the entity or create a new one for updating, only one update query runs. Next, let's explore how the merge method isn't just for updates. It can also create a new record if the ID field in your entity object is null or doesn't match any existing row. Here's what happens. If the ID is null or JPA can't find a matching record, merge treats the entity as new and inserts it into the database. If the ID does exist, it updates the corresponding row instead. Alright, now here's an important update, literally. In older versions of Hibernate, if you called merge with an entity whose ID didn't exist in the database, Hibernate would silently create a new record. But in the latest versions of Hibernate, things have changed. Now, if your entity has a non-null ID, but that ID does not exist in the database, calling merge can throw an optimistic lock exception. So what does that mean for you? If you're trying to update, make sure the entity with that ID exists. If you're trying to insert, either leave the ID as null or use a proper insert logic like persist instead of merge. This change helps avoid accidental inserts when you meant to update. It enforces data integrity, which is a good thing, but it also means we need to be a bit more careful. Okay, now let's put this into practice. We're going to create a new REST API just for demonstrating the merge behavior. Create a new endpoint, let's call it /merge method demo. Do the same as I do on my screen. Okay, I'm skipping the find and locking stuff for now. Let's just focus on how the merge method works. Now let's convert employee DTO to an employee entity. In the Demo Entity Manager repository class, we'll create a method called updateEmployee1. And inside this method, we'll call the merge method provided by the Entity Manager. Next, wire this up with our controller. Alright. Here's something really cool about the merge method. If the employee ID in the entity is null, then Hibernate treats it as a new record and inserts it into the database instead of updating anything. First, we need to make a quick but important change in our employee entity class. Right now, we're using a primitive type long for our employee ID field, but we need to switch it to its wrapper class long. Why? Because when we use long, it always has a default value of 0, so it can never truly be null. But Hibernate uses null to decide whether to insert a new record or update an existing one. Now if you look at our employee DTO class, you'll notice that the employee ID field is still a primitive long, which means it'll never be null. It'll always default to 0. Now I don't want to change the DTO for now. So here's a smart workaround. In our controller class, right before we call the merge method, we'll simply check if employee DTO.getEmployeeID equals 0. Then we'll set the entity's employee ID to null. Awesome. The changes are in. Now let's start the application. Alright. Let's take a quick look at our table. See here, the last employee ID is 62. Okay, now I'm going to hit the API with employee ID 65. But remember, there is no employee with ID 65 in the database right now. So what will happen? We got an exception, just as expected. Okay, let's quickly check the database. As you can see, no new record was created. Check out the console logs, you'll see it's an optimistic lock exception. Now take a look at the exception message on the console. Row was updated or deleted by another transaction, or unsaved value mapping was incorrect. This is a classic optimistic lock exception, and it usually means one of two things. Hibernate tried to update a row in the database, but it couldn't find it. Or, the row was already deleted or never existed in the first place. This behavior actually depends on which version of Hibernate you're using. If you're using a lower version of Hibernate, then EntityManager.merge will happily create a new record, even if you pass an ID that doesn't exist in the DB. But in the latest versions of Hibernate, it's stricter. If the ID is not null and doesn't exist in the database, Hibernate won't create a new row. Instead, it throws an optimistic lock exception, like the one we just saw. Alright, now let's test something important. This time, I'm going to send a request with employee ID equals 0, which basically means we want to treat it as a new employee. In our controller, remember we already added logic. If employee ID is 0, we're converting it to null before passing it to the entity. Awesome. We just got a successful response, and look at that, the new employee ID is 63. Let's quickly jump over to the database. It's right there, a new row inserted with employee ID equals 63. So what just happened? We passed null as the ID in our entity, and as we learned, when EntityManager.merge sees a null ID, it knows this is a new record and not an update. So it silently inserts it into the database, no extra config needed. So be careful when using the merge method. It might seem simple, but there's a catch. If your entity's ID is null, then merge method doesn't just update, it will insert a new record. That means, if you accidentally pass an object with a null ID, Hibernate might silently insert a new row, leading to duplicate or unexpected data. Alright, let's quickly summarize what we learned today. We explored multiple ways to update records using JPA, using JPQL, using the Criteria API, and the powerful yet tricky merge method. We also learned how merge can both update or insert based on the entity's ID, why sometimes you see two update queries, and how to avoid that using detached entities or fresh objects. Whether you're a beginner or brushing up on advanced topics, I hope this session helped clarify the real behavior behind JPA's update operations. In the next video, we'll dive into exciting new things. Don't forget to subscribe, like, and hit the notification bell so you never miss an update from this series. Thanks for watching. See you in the next one.